Right, registers are going around, make sure you sign them. So if this can stay this side, oh, that's almost working. Right, and if that can just do this side. Okay, if we can have one register go down this side, that's the one, thank you. And if that can go down that side, and can you make sure everybody up there signs that and it comes back to me at the end? Right, main thing you've got to know. Next Tuesday, so a week tomorrow, midterm tests. This is an assessed test. It matters. It counts towards your coursework grade. If you miss it, you get 0, and that could mean you get 0 for the coursework as a whole. So you've got to turn up, you've got to do it. Make sure you bring your ID cards, i.e. these things with you, because get into the habit of it. You're not allowed in an exam without your ID card. So in the summer, if you turned up to an exam without this, you'd be sent away. And you wouldn't have enough time probably to go and sort it out and get back in time to be allowed back into the exam hall. So get in the habit now. Any test, you take your exam, your ID card with you. What is the midterm test on? It's everything in workbook 1, part 1. So everything up to and including what I do in this lecture. So that's variables, assignment, expressions, types, records, getter and setter methods, methods in general, passing arguments to methods, if statements, and for loops, which the last two I'm going to cover hopefully in more detail today, and I'll do a little bit of review of some of that next week as well on the lecture on Monday. But is everything in part 1 of the workbook. I'm just getting part 2 of the workbook printed, so I'll get copies of that out to you sometime after next week, essentially, hopefully by Monday. If you've got any other queries about it? Oh, and the other thing about the midterm test, it's in your lab on the Tuesday, so you've got to turn up to the lab you're supposed to. What else is there about it? Oh yeah, and if you were to miss it because you were ill, then you need to fill out an extenuating circumstances form at the ITL office, and you need documentary evidence of that. So whatever reason you have for missing it, you won't be given anything other than a 0 grade for it unless you've got a good reason, and that good reason is actually supported by evidence. So that means if you're ill, you do need a doctor's note, okay, to prove you're ill on the day, and it's got to be a doctor's note that covers the day of the test. And I don't have any say, particularly in the decisions about whether anything is a good enough reason. It's all done sort of by the admin office, by the Extenuating Circumstances Committee people. So if there's some reason why you are going to miss it, you know, in advance, you'd better go talk to them soon, because if you do miss it, you're essentially stuffed. The best case that's going to happen if you miss it without a good reason is your mark is going to be capped at 40%. The worst is that you'll get 0. And that's your overall mark for the coursework. Don't forget past sessions on Wednesday. That's one other place during the week to get help. So if there's specific things you're not sure about, you can post questions on the forum, but you can also go to the past session on Wednesday as another place to get help, and obviously ask questions of people in the labs this week. So any questions about that, about what's coming? Oh, the other thing I was going to say is what you need to be able to do is explain concepts, so expect questions like explain the following, justifying your answer by reference to either an example you provide or an example in the question. You've got to be able to dry run programs, so draw trace tables and justify your answer, i.e. a trace table that shows how you got what your working was. And you've got to be able to write programs that are about the same complexity of the short exercises or the earlier stages of the mini project. And all of that could include all of the stuff that we talked about, including if statements, for loops, that I'm going to cover today in more detail. Okay. So any quick questions about anything about the midterm test? Yes. Sorry, how? There's 430 of you, as fast as I can mark them, and I'll be marking my socks off basically for the next week. Yeah, so I try and get grades back within 2 weeks. I try and get some feedback back to you before that, so I'm hoping I'll have some kind of feedback sheet posted sometime next week, which won't tell you your marks necessarily. You'll probably get your papers back in either 2 weeks' time or possibly 3 weeks' time, depending on how fast we manage to get through the marking. But basically, as fast as I and the team of people I've got doing it can mark them. But I'm aiming for something back to you next week, certainly in 2 weeks. So you've not forgotten about it by the time I get you the feedback. Any other quick query about that? Okay. So, what we were looking at last week were programs like this, and I think this was the program I looked at, and I hope those are, with the addition I just did, are basically the same program. Push it up. Doesn't quite fit on, does it? Okay, so what I'm going to do is basically do the rope stuff as an example of exactly what's going on here, because there's things about if statements that people get confused, so I want to make sure nobody gets too confused about that. So if you four don't want to sit down, because I'll use you, actually, given you just got here. Okay, stand up, the four of you. Come on, stand up down here. You're a volunteer, you just arrived while I was talking. Put your bag down, you can do that. I'm not cruel. Okay, you two as well, if you'd just like to stand up and form a queue down here. So, we got a program here. When I was doing this with the rope last time, when I was over that side, basically, what the programs we looked at were all straight line programs like this. You had a series of instructions, he'd have an instruction he'd do, and then he'd have an instruction, and then he'd have an instruction, and he'd have an instruction, and you'd do them one after another. So I'd rope them in a straight line. Okay? Now this program is different. Could you two come over here, because I need 2 more volunteers. So you can put your bag downs over there. And I may use people upstairs as well at some point, because if people are starting to think, oh, you can escape upstairs, then one day I'm going to appear upstairs and I'm going to lecture from up there. And all my volunteers will be up there instead. Brilliant. You can just put your back down for a moment. So, the thing about this program is it allows us to do different things. And the things people get confused about are kind of what happens sometimes, you know, at the end, or do all of these instructions get followed or not. And the point about a program like this is what it does is it splits into 2. So I want to just show that by showing you what the structure looks like, roping people up. If I compile this into people, then what do we get? He's trying to escape. No, okay. He's just signing the register. Okay, you can go at the end somewhere. Okay, you go stand up at the top of the stairs. So what kind of program have we got here? Okay, further down, we'll use the whole of the stairs here. Somebody's going to get to sit down, possibly. I don't know how this is quite going to work. Oops, and I also need the actual instructions, which I've managed to not come with. Do you want to just wait there at the front? Okay, sit there, that's where I can see you, and then if I need you, I'll come and use you. Okay. So, what's the first instruction I've got there? It's string ants, it's just declaring a variable. So that's your job. Your instruction is string ants, I'm compiling that to you. So essentially what you do is it's declaring a variable called ants. You've got to pick somebody to be a variable, and they kind of store anything you want them to store. Okay? So you hang on to that. So the next instruction in the sequence is ants equals input string. That's getting an answer. So input string is just a method I'll have written somewhere else. So what your job is actually to get some code over there somewhere, like those people, to execute something, and then they'll pass the baton back to you. But we'll forget about exactly the detail of that. You just get something written onto the board. Okay, we then keep going, and the next instruction, go on, sign your name. It's called multitasking. So the next instruction is actually the if statement. So this is where something different happens, because the if statement, if ants equals yes, is actually doing a test to decide which bit of code gets executed. Okay? So that's your instruction. And what happens here, it goes multicolored, because there are two different paths through this code. Actually, this aisle probably isn't really wide enough to do this. So can you go and stand there? Because we're splitting into two halves. So stay stood there. And what happens with an if statement is instead of this sort of one line of rope going all the way down, we actually go in two directions. So if you want to come, and you can stand in the gap there. So we had a straight line bit of code, but now it's actually split in two. And oops, it's cosmic rays hitting my program. It's split in two. There are two different ways my baton can go. When I'm passing the baton, before it's just always, oh, just pass it on to the next one, pass it on to the next one. But now there's two ways it can go. Okay? So the program actually splits into two parts. There's one part which is the print you smell, and the other part that's print you smell of roses. I'm not, in any run of the program, going to do both of those. I'm going to go one way and do one thing, or go the other way and do the other. So have I got the pieces of paper? And I never know my left from my right, and it depends what I wrote on there. So if what is exactly the string less, then pass the baton down the rope to your right. My right is that way. So yes was that way, so that's that one. And then the other option is smell of roses, which goes that way. And why I'm belabouring this partly is because what people get really confused about is what happens next. Okay? And what happens next is the two branches, even though they're in a straight line down my page, because you've got to write things in a straight line on a page, what it actually does is it joins back up again and carries on. So even though it looks like those are sort of somehow one after another, actually you're doing one thing or the other. And the thank you line that comes at the end is actually something that's on both of those branches. Because what happens now, actually let's make a blue branch and a white branch, so you take that instead. Okay, so what happens after that instruction's done is we wire it up so that the thing that prints thank you goes there. And what happens on this one, also the same thing, let's give you blue, might as well be color-coded, it joins up as well. Okay? So if you want to step back a little bit just to make the rope straight, oh don't, because then he drops it. Now, what's the structure of this code that I've compiled? On the paper, it's line after line after line, but in reality, what gets compiled to is something that has this branching structure. So there's no way on any run of the program both of those things can be executed. So if we actually go through a sample execution, if I try not to strangle myself and make it my execution. So I'm God, we're running this bit of program, something before this has happened, we've called a method that's got this code in it or something, but eventually it comes to him. What is his job to do? Well, he's creating a box. I didn't bring any boxes with me, so let me try not to strangle myself again. So you're unique here, because what does it mean to declare a variable? What is the command you're executing? It means pick somebody to be that variable. So you're the command, so pick somebody at random. It can be somebody coming in late, or it could be just somebody nearby. Okay, last person in. Person who's just sat down there, we need you up here. Just leave your bag there. Make sure you don't get strangled as you come past the rope. Okay, you can stay down there because we can do this at a distance. He's just picked you as a variable, right? So what is his name? Ants. Whatever your mother called you, forget it, you are now called Ants. Okay, so if anybody ever wants Ants, you're it. Okay, do you put anything in there? No, because the way I've written it there, it's just a declaration. It's not got an initialization. Okay, initialization, remember, is when you put the first value in. We're not putting the first value in that line, so you've now finished your job, you pass the baton down. And at this point, what's happening at the top of the program is nothing special, it's just batons being passed from one instruction to the other. Okay, so here's now the next instruction, which is input string. So what he will get done is print up on the board, we won't bother doing this, you can imagine this, but up on the board, on the screen, you get to be printed. Can I insult you, please? Okay, so that appears, that's what we've programmed input string to do, and that method is going to just wait until you type something. So you've just been asked a question, you can be the user of the keyboard, you're being asked, can I insult you, please? What is your answer? Yes. Okay, was that lowercase y-e-s? Let's assume it was. So you type lowercase y, lowercase e, lowercase s, and hit return. Okay. So what happens to that lowercase s? Well, we've got a variable assignment there. So input string is an expression. It's something that's there to get a result. It's a function call. So it's a method call, but the kind of method call it is a function call. What does that mean? It returns a result. And so you've always got to have something to do with the result. The result it's just returned is the string yes. So we've now got to do something with that string yes. And that command, where does it tell us to put the string yes? Where do I put the string yes? In ANS, yeah. Okay. So we've got this string yes, and you created somebody called ANS, and that's where we're going to store it. So he knows his name. The moment I mention the name, he comes and grabs the value from me. And that's where it's stored, so if we need it later, we can use it. Okay. Again, this is just revising stuff we did before. Okay, so that function calls over, it's part of an assignment, the value it returned got stored in the variable, because that's what the assignment says, ANS gets the value, whatever's returned. And then you pass the baton on. And now we get to something that's going to be slightly different if it doesn't all break apart. You needed 3 hands, didn't you? So, what is his job? He is basically the test. So, that word if is really just a placer, a keyword that says something different is coming, that create this structure. What actually is the bit that does the work is ans.equals yes. And that's another function call, essentially. It's a bit of code that's an expression, and expressions aren't whole commands. The whole command here is the whole if statement, the if blah, 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 else blah, blah, blah. That is the statement that does the work. Embedded in that is something that is an expression, something that needs a result. So Dot equals is really a method call that just gets you an answer, but it gets a special kind of answer. It's an answer that's a Boolean. So a Boolean is just a type. Instead of integers, which are 1, 2, 3, 4, Booleans have two values, true or false. Okay? They can be nothing else other than true or false. So what you put there is always a question with the answer true or the answer false, one or the other. And that's why it works in this case, because I've got two ways that I want the baton to go. Either it's going one way, and it goes that way if it's true, goes to the first instruction, and if it's false, it goes the other way, it goes to the second instruction, and skips the one it didn't go to. Okay? So, what does ans dot equals yes actually do? It goes and looks in ans, gets the value out, it's now holding a string, and that string is yes. And we ask, is yes exactly the same as the string I've put there? Yes. So we're asking, is yes equal to yes? And in particular, we're actually asking, is the string lowercase y, lowercase e, lowercase s exactly the same as lowercase y, lowercase e, lowercase s? Is what's in that variable exactly what I've written in the code of the program? So is that true or false? Is it true or false that yes equals yes? It's true. So you've got to answer that question not yes or no. You've got to answer that question true or false. Okay? So it's true. Yes is the same as yes. That's always true. So because we've got yes in the box, the baton goes the next way, and you needed more hands as well. Right. Okay. So what we've done is completely ignored this person over here, which was the you smell of roses line. That bit of code is just being completely bypassed as we go the other route down the code. Okay? So we've gone this way, and what do you get printed up on the screen? You smell. Okay? So you asked, can I insult you please? And you said yes, and so it prints up you smell. Okay? And what happens then? That's appeared on the screen, and the baton just carries on. And at this point, it gets to this joining point, which is the point immediately after the if statement. So if there's an instruction there, that instruction gets executed whichever way it goes. Okay? And so what do you... So you get thank you printed up on the screen. Okay? So, everybody follow what this code is doing. Okay, let's take the baton up to the back and do the other way. Let's suppose we did the same thing. Again, we created a variable called ans. So take the value in there out. It's a completely different person, different box. It's empty. Okay, we pass the baton on. And now we ask for you to type something else again. So this time, input something other than yes. No, somebody said. Okay, how are you spelling that? N-O, lowercase. Lowercase n, lowercase o this time. So this time, we've got... We'll get to that in a moment. Does it matter whether it's lowercase? This time we've got no in there. So now what are we asking at this point is the string no the same as the string yes? Is that true or false that no equals yes? It's false. And if it's false, the baton this time goes that way, and this time we print up you smell of roses instead of that way, and this time we completely bypass that code. So this second time we run the program, a completely different bit of code gets executed. But when we've printed you smell of roses up on the board, again, the baton goes back to this joining point, and at that point you print thank you, and then, then it carries on. So if you just mind out of the way, because you're just a variable, you're not anything very important right now, I want program. You know, so this program presumably carries on. Maybe there's a return statement or something after it, and what we've done is we then just carry on doing things one after another. Or there could even be another if statement here that sends us in two directions again. But what's happening is you've still got this sort of straight line running down through the program from the top to the end, but you've got this branch that you're going one way or the other. Okay? So, let's just go back and think about other things that might happen. So, anybody got any questions about this while this is set up? And I can point to particular things. Anything anybody's not sure about what would happen in any situation? You're all happy? Okay. So, somebody just asked, does it matter whether I use uppercase or lowercase? So let's suppose what you actually typed in at this input point was actually uppercase y, lowercase e, lowercase s. So let's suppose variable, and let's suppose throw that away, throw your old value away. This time you've got uppercase y, e, s. What is going to happen now when we get to this point? So we've just inputted and we've come to this point, we've come to the question again. Is that true or false? We're asking, is yes equals yes? But one of them is lowercase and the other one is uppercase, y, e, s. True or false? False, yes. They're not exactly the same because it's comparing them character by character. So because it's false, even though you typed yes, it would go this way and you would get insulted. Sorry, it would go this way and you've said equivalent of no, so you wouldn't get insulted. Sorry, I'm getting confused now. Okay, so it's false, so you go this way. So whatever test you put there, you're checking that test exactly. Okay, and there are other methods you could call that would do different tests, but dot equals is testing two strings. Are they exactly the same character by character? Okay. So similarly, what would happen if you type something else like no all uppercase? Well, is no equal to yes? It's false again, so again it goes this way. If you typed wombat when you were asked yes or no, which way would it go? Is wombat equal to yes? No, so it goes the false way again. The only way that program can go that way is if ans exactly equals yes lowercase, all lowercase. Okay? So, any other queries about what goes on with a program like this, with an if statement in? Yeah. So if you write equals equals instead of dot equals, if you write dot equals in lowercase. Oh, yes, so there are other methods. So there's one that's dot equals ignore case with some spelling or other, I can't remember, with its capitalization. And that's a different method you're calling. It's a different method. Somebody wrote a whole series of different methods for different things you might want to compare. So if you wrote dot equals ignore case, i.e. some method that's a slightly different one, in that case, that method was written to check whether two things are equal, where you convert them both to lowercase first and then see if they're the same, essentially. So it just ignores anywhere where you've put uppercase and assumes they're the same, because that's obviously something you might want to do. What happens if you use either dot equals or equals and the person typed y instead of yes? Is that true or false? Yes. It's false again whether you have the ignore case version or the dot equals version. Okay? Another thing that would go wrong is if you wrote equals equals there, ans equals equals yes, that would actually do a completely different kind of test that I'll explain in a few weeks' time. But when you're comparing strings, this is really important. You've got to use dot equals. So dot equals for strings, equals equals to compare integers and various other things are the same. Okay? So, any other queries? Yeah?
And you have two options for the true pathway, so you could have lowercase yes and uppercase yes.
Yes, and I'll come to that in a moment. I'll show you an example of doing that when I get back up there. It's probably easier than me trying to change things down here to show it. But the answer is yes. So obviously there are variations you want to do of that, where you could say, well, I'm happy for them to just type y. How do you do that? How do you answer a kind of compound question that's got a series of parts? Did they type this, or did they type this, or did they type this? And that's essentially what you write. You just have an operation all that combines things together. But I'll show you that with an actual example. Any other queries about what happens and why the tube goes one way, control goes one way or the other way? Right, okay, put all of this lot down. You lot can go and find somewhere to sit. Give them a round of applause for being such wonderful people, for coming in late just when I needed them to. And while I'm collecting things up, think if there's anything else about if statements you want to ask me. Just stick it all on top. Any other bits? Is that a bit of mine? Right, so answering that question and also doing something slightly different as well. Here's a variation on the same program. So this time, what I'm saying is you've got several choices, and instead of answering yes or no, I'm saying you can answer A, B, or C. So it's kind of multi-choice sort of thing. And again, I'm doing the same thing. If answer dot equals A, then do something. If answer dot equals B, then do something else, do something else. So I've given multiple choices in two ways. And this is the answer to wherever you've gone, your question about what if I want to say one thing or another. So that's what I've done here. So I'm saying if answer equals A or answer equals a capital A, I'm giving two questions, and how am I combining? I'm combining with that symbol there, and that symbol there just means or. Two vertical lines is just saying one or the other. But you have to write the whole thing out. You can't say if answer equals A or B. You've got to say if answer dot equals A or answer dot equals B or answer dot equals C, whatever the options are. Or in this case, lowercase a or answer dot equals uppercase A. You've got to write the whole question out, because that thing that I've bracketed is an expression, is something that's got to return true or false, so it's got to be a complete expression. And this whole thing is a complete expression as well. It's an expression made up of two sub-expressions. Each of those sub-expressions returns a true or false value, and what OR does is combine them. It looks at the two answers it's got, and if one of them is true, then it's happy for the answer is true. But if both of them are false, then it gives the answer false. That's what we mean by a Boolean OR operator. And you can also have AND in there, and this is something to be very careful of, because all the time people write AND when they meant OR. So here we're saying, is it that or is it something else? If we put AND in there, which would be an ampersand sign like that, that's saying, is it equal to lowercase a and the same thing equal to uppercase A? And it can't be. There's no way answer is both lowercase a and uppercase A at the same time. So if we put and there in this particular situation, it would always give the answer false. There's no way it could be anything but false. But that's something that you might want if you want answer 1 equals A and answer 2 equals B. Then you want an and there. You want this to be true and that to be true. But in this situation where you're saying, you know, uppercase Y or lowercase y, uppercase A, or whatever, it's all that we want. It's one thing or the other. And there's also operators for saying not as well. So if it's not that or that, then you can write expressions like that, which I'll get to in a moment. Okay? So what is this program doing? If we just look at the first part of it, it's sort of up to there. It's more or less the same. It's if answer equals something, and then we've got an option to do, and then we've got an else, and then we do something else. The subtlety here is all of that is just a single statement. So essentially what I'm doing there is exactly the same as the simple case I have there. I've got, if it's true, do this, else it's false, then I've got to do what's in the box. It's just what I've put there in the box. Instead of just being some assignment statements, now the else case, the else branch, it has got a test of its own. So you could actually just put curly brackets around the whole of that, and it's the same thing. If, and then do what's in the curly brackets, else you've got something in the curly brackets, which is what you do. Okay? And even though we write it in this slightly different way, because it just is easier to read, if you say if something, else if something, else if something, else if something, and then end with the final else case, actually what you're doing is exactly the same. You're just using if-elses and putting an if-else inside an if-else. And in terms of what is happening, you know, with the rope coming down here, what we've got is, if it's true, then we've got a nice simple thing to do. We've got something to do, and then we join back up. But if it's false, what is it there? Instead of a nice simple thing and then join back up, what we do there is actually split in two again and join back up and join back up. So we've got another true-false case that we've stuck, and that what's in the box there is just another if statement that's acting in the place of the statement. So somebody asked me a question about this about a week ago, about this kind of structure, so I've given an answer on the forum to this, which is go read that as a little bit more background as to what's going on here. But this is, as well, something that people then start to get confused with, because what they do is they start putting a test here on this final else case. But the whole point of the final else case is not that it's a test, it's just a catch-all. So if what went before didn't hold, then this is what you're going to do. So you don't ever have anything after the else case. That's just catch everything that we haven't caught so far. So this is saying, if this is true, then do that. Else, if it wasn't true, then we're going to do what follows. But now we're doing another if, else, if this is all true, then you'll do that. Else, if nothing's caught it so far, then we'll do the final case. Okay? So any other questions about that, or anything that was raised about if statements that you're not sure about? So everybody happy? Okay. So this is a simpler example of what I was just showing, where what can go inside the curly brackets can actually be anything that we've seen so far. So you can declare variables in there, you can have a whole series of statements, you can have other if statements. So what the curly brackets actually do is just group sequences of statements into a single statement. So it's if this is the case, then do that statement, and that statement is actually a series of statements. In this case, I've just put 2 print statements. Else, you've got a sort of mini program in there. It could actually absolutely be anything again, 2 print statements. But the point is, whichever way you go, whether you go this way or you go to there, in both cases, when you've finished, you carry on with the rest of the program that comes after it. Okay? So curly brackets are actually creating something called a block, which is a statement that's made up of smaller statements that are just sequenced one after another. Okay, everybody happy with that? Okay, so if you did understand what I've just been talking about, write a little method that does this. So what I want is basically something more or less what we've just been looking at, and I'll put that back up, but something that asks the user to type in the name of a pet, whatever pet they own, and then prints out a suitable message depending on what they type. So if they type dog, it prints out one thing. If they type goldfish, it prints out something else. If they type cat, it prints out something else. Don't care really what it prints out, but it's going to do something different depending on what they type. You can assume you've got an input string method like the one I just had to actually input the values. The other proviso is you're only going to, in the program, name a few kinds of pets, but you should always have a situation where you can handle anything they type. So if they type something the program doesn't recognize, you should just print not heard of that one. So just print some message that sort of shows you don't know what it is. So you've got to say something normal. So let me just go back to well, let's put that there, and I'll put this longer one up here. So it maybe is something a bit similar for that program. So have a go at doing that, and if you're not sure what you're doing, stick your hand up, because this is the kind of thing that you've got to be able to do by next Tuesday in the midterm test. So if you don't make sure you can do it now, then you're probably not going to be able to do it next week. So anybody with any queries, anything you're not sure about, just stick your hand up. Okay, there's somebody up there, but I'll come to you first. Yeah. Ah, good point. So I get bored of writing system.out.println out. So what I tend to do in programs is I just write a print method which is called print and just calls system.out.println. So this program itself isn't a full program. There are other methods that go with it. One of them is the method input, which is like the one we were just talking about, but also the method print. And that there's an advantage to that, because my programs, if I decide to switch them from being console programs to popping up windows, all I have to do is change my two methods, the print method and my input method, and then the whole program will just work in Windows instead of working in the console. So it's one of the reasons you write things in methods. It means you can make changes and they happen everywhere. So if I wrote system.out.println everywhere, that means the program is basically committed to printing things at the terminal in the console window. By putting it into a method that actually is, if I'm writing it lots, I don't have to type as much out anyway. Essentially, I can change the whole program by just making one change, and the program can flip from working one way to working another way. Okay? So print and input here are methods that I've written separately. I'll put those up in a minute. I think I've got a slide with them on. Yeah.
Why do I need Boolean?
Oh, so I didn't mention this, but this was just illustrating Booleans. So Booleans are just values. You can declare variables. So here I've declared a variable Boolean, an insult, and then I'm setting it. And sometimes that's a really convenient thing to do when you're doing an if statement, to keep track of whether you answered one way or another way. If there's a sort of categories of answers and you want to keep track of them, it might not be a Boolean you use. You might use some other variable to keep track of it was type A of answer or type B of answer. But it means at the end, I can then do a check on that Boolean and see what that Boolean was, and it tells me something about the answer. And in this case, I'm using it to tell me whether what they actually typed in was a valid answer or not. And if it wasn't a valid answer, then the last thing I can't really remember because I haven't looked. Oh no, I haven't put a C case. So what input the insult is doing is telling you whether you didn't want any kind of insult. But a common way you would do that kind of thing is if you just wanted to keep track of the fact that they actually typed an invalid answer, and if they typed an invalid answer, you'd want later in the program you want to do something completely different, like go back and ask them to do it again. And keeping a Boolean like that is one way to do it. Any other questions from anywhere?
With regards to the multiple answers, is there something quick to say, if you've got Queen Mary and someone turned on caps lock, so it's Q, capital U, E, E, N, like, is there like something to, instead of doing this multiple times, cover all possibilities?
So is there a way of dealing with sort of multiple possibilities? To do with case, yes, there's this method that he was talking about, which is an equals ignoring case. So if you look in the string library, there are all sorts of methods that people have written already. Essentially, all that's happening there, though, is somebody else has done the thing you're too lazy to write yourself, which is written a bit of code that covers all the cases and does a transformation of them for you. Okay? So yes, there are methods there that make some of this easier so you don't have to ask everything. But if there's very specific things you want, like you're happy to take Y as an answer for yes, then you're probably going to have to write it yourself. But if it's just things like uppercase, lowercase, which are quite common that people might want to be able to just treat them all the same, then somebody's already written a method to do that for you. But explore the libraries. I'm not going to go into all the detail in the libraries. I'm just going to take some of the basic kind of methods that are the core methods you need to do basic stuff, and assume that you can go and look in libraries to find other stuff. Any other query or anything anyone wants to be? what in answer dot equals A. So what that's saying is, even though in the question I said type lowercase a, lowercase b, or lowercase c of the answer, if they type an uppercase A, I'm going to accept that. I'm not going to quibble about that and treat it as something different. Okay? One of the things as well about this isn't a particularly brilliant program because I've used my else case to mean not at all. So I'm treating the else case as they actually type C in. But what if they type something like wombat? Actually, maybe I want to do something different, not just treat that as them saying they don't want to be insulted, but treat that as being they got confused and they answered incorrectly, and I ought to go and ask them again to check that it wasn't a cat walking over their keyboard or something while they were getting a cup of tea. And so what your else case really ought to always be is something that is a catch-all, catching the cases that you haven't thought about or that you haven't explicitly said you wanted, and make it an else-if case for all of the cases that do matter, and then just put an else at the end, which is you didn't answer what I want, or the situation isn't one of the ones it was supposed to be. Okay? Yeah. You can't make it restart the program itself. You can, once you quit the program, then the program's ended and the program's got no power over anything anymore because it's not running anymore. What you can do is, and this is what we'll do in the second half, introduce loop statements that say go back to the beginning. So you're not leaving the program, you're still inside the program, but you can say go back to the beginning and do that again. And that's what I'll be doing over the next couple of weeks, actually several ways of doing that. So the separate parts of the if statement here, because they're small, I've just written instructions out. If you had lots of instructions in each separate branch of the if statement, a good thing to do would be to write a method to do each thing. So you jump off and have a method that covers the if statement true case and another method that does the false case, or if it's a staircase of them, one for each type. So it's good practice quite often, depends on the situation, but it can be good practice to just have a method. If you've got anything that's self-contained piece of code, it's a candidate for putting it into a method. If you could write in a sentence what that bit of code does and it makes sense, then think about it being a method. You know, when it's just an odd line of code like this, you probably wouldn't. But one of the advantages of this, if you expand the program, having things in methods usually makes things easier to kind of expand. To, you know, if we wanted to do more than just use smell of a particular thing, then, you know, do some calculations or whatever of the amount of insult we're going to give them or something, then calling methods is often a good way of doing it. For the same kind of reason I'm using print here, because it makes it clear which bit of the program you need to change. And also, quite often, you'll find you're actually doing something very similar in each case, and you could call one method that does justice past an argument and does the right thing depending on what it's called. You just call the same method with a different argument to do the different branches. Yes. Last thing. Yes. What? So it would be a different structure. So actually, let me go back up and answer that. So if what you did was put an if statement and then an if statement, and maybe you'd even got an else in here, but if you didn't have the else there, it's actually doing something subtly different. So what that says is, if this is true, do that. Well, actually, let's talk about what the version that's there at the moment is. If this is true, do that. If it's false, go on and ask that question. Okay? So you will only ask that question and do any of the rest of the else if statement if that is false. Okay? So if it's true, you do that and then jump to the end. If it's false, you jump to here and carry on with this. If what you did is treat them as two separate if statements, you've got a different structure. This says, if that is true, do this, and then carry on. If it's false, you also carry on. So that would mean you'd actually end up doing this in the case when both when that's true and when it's false. So in the structure that I've got here, the moment you found a true statement, you jump right to the end. Okay? If you didn't have the else, then you've got two separate statements that are just now doing things one after the other. Okay? So, I seem to have lost my slides. Oh, there they are, the slides. So it's the difference if you have if something else and then if you have that structure, so you've got an if-else followed by an if-else, what you're doing is you're splitting once, and then that's the first if statement, and then going straight to another if statement and splitting again. So you do one or other of these, and then whichever way you went, you also do the second test, the second thing. Whereas if you've got if something, do whatever, else if do something else, that's a different structure. That's saying if it's true, do this and jump to the end, but if it's false, do another test and possibly then jump to the end or go the other way. So it's do all of this and then do all of that, whatever the answer, or only do this if the answer was false. So it's subtly different. In some programs, it won't actually make any difference because the logic will mean you get the same result, but there'll be some situations where it is subtly different. So it does make a big difference as to whether you're chaining whole if-then-elses one after the other, or you've got an if-then-else inside the else case of something. Does that make sense? Are you wiser? Okay, let's just go through what kind of thing you would get with a question like this. So what are we looking for? So it asks for a method, so we've got to write a method. And notice the way I write these things. Whenever I write an open curly bracket, I write a closed curly bracket somewhere straight away because otherwise I'll forget. So we want some kind of variable that will be a string pet to declare at the beginning, which is their answer. We'll then say pet gets input, whatever it asked us to do. It's whether they own a pet. Or what pet do you and then I'm going to have a series of doing different things depending on what the answer was. So the answer is in pet, so if pet dot equals then dog, then I'm going to print one thing. And then else, because it's always if else, but this time what I want to do is ask another question. If it wasn't that, what I want to do is ask another question, so I start another if pet dot equals cat, then I print something else. And maybe I've got a whole series of else ifs in there, but then I'll finish with else, and the else doesn't have anything after it. It just has a statement, else. What did I say? Not heard of that one. And now I'll move that down a bit, and the last thing we probably want to do is just return from the method, so I'll stick a return statement here. Okay. Oops, and that was off the bottom. Tell me if I start writing off the bottom, because I can't always see what's going on. Okay, so you should have ended up with something like that, and you could, in the time you've got, perhaps have made it more fancy and allow them to type upper and lowercase variations of dog, or give them different variations of them typing fish or goldfish or whatever. But roughly that's the kind of structure you've got. Okay, any questions about that? Not sure about why the answer was the way it was? Yes. Hang on, I can't hear. Shh, everybody. Let me get a bit closer.
You see the last program, you had an extra line that said something is equals true. Why don't you have it in this program?
So why haven't I bothered putting, in the last program I had an assignment insult gets the value true. So in this particular program I couldn't see any reason that I would use it, but it may be what you want this method to do, for example, is return a result that tells you whether they typed in something sensible or not. So what you might do is set it, good pet gets the value true in all of the cases when they type something you knew. If they type something where you said I hadn't heard of that one, then you might want to return false instead of true. So you return that variable value just so that whoever called the method knows, oh, they haven't given me a pet, so don't carry on the conversation as though they gave you an actual pet. So it's just storing in a variable some value that tells you something more generally about what they did. So in the earlier thing, I just did it as an example of using Booleans as having Boolean variables that just hold true or false values. And I couldn't see a reason here. But if you put something in, then it's not necessarily a bad way of doing it. So I started void, and so I can return, but I shouldn't put a value after the return. I'm not returning anything. That's what void means. So if I put return insult or return pet that returns the answer that they gave, then I wouldn't want to do that. One last thing, and then we'll...
Pets after void, is that a variable? Is that a value?
Pets after void is the name of my method. So it's an identifier, one that I've invented, could have been anything, but it's the name of the method. So if I want to call the method, that's the identifier I use if I want to jump to this bit of code. Okay? So what I haven't done here is put a context where you're using this method, where you actually call it. Calling it is when you jump to it, do the code and jump back. How do you know which bit of code you want to jump to? It's just from the name, and that's the thing that always comes after public static void. Or it could be a different type other than void. Okay, we're up to the hour, so I've got quite a lot to get through, so I'm going to have just a quick 5-minute break as normal, but then I'm going to talk about for loops and hopefully cover for loops, which again you do need for the test next week. Okay, so you need to understand both what I've just done and what I'm going to do in the second half. Anybody got any questions, come and ask me in the next few minutes, and I'll also be around after the lecture, sitting outside if people have got more questions to ask me. Who hasn't signed the register? Can somebody make sure a register gets to the person in the top corner who hasn't signed? Can all the other registers come here? And the one you end up with got to get back down here as well. If anybody's missed it, I'll leave it on the front corner here. They certainly could come up because they're in the workbook, but they're not likely to be a major part of the test as such, because obviously there's a lot of material. Yeah, well, with any of it, any single thing isn't likely to be kind of a massive part of the whole tests. And if you've got the hang of records but not getter and setter methods, and there's a context when in the program you needed to use records, then if you don't think you can do it with getter and setters, just do what you can do, which is do it just as a record without the getter and setter methods. But what you do need to know for the test is definitely how to call methods, they return values, how you can pass information to methods, which is actually all getter and setter methods are doing. Okay? Right, who was next? Yeah. So yes, so all that happens there is when you declared it, you initialized it as well and immediately put a value in. But then that value is immediately thrown away in the next line when you put a new value in. So it's generally good practice to get into the habit of when you declare variables to initialize them and put a default value in that isn't going to cause any harm. So usually it's something like 0 for integers or an empty string for strings. But in this case, because the actual assignment to it is immediately the next line, it's probably a little bit pointless to do it there, and actually you could have just combined the two lines and add string ans gets the value input string. But and that's sort of why the version I've got here is actually slightly different to that, because there's not really a point. But it's good practice to always initialize values, because then what you want is the program not to crash if you end up with some route through the program that you didn't think about, just because there isn't a value there in the variable. Okay, so if you put a value in straight away, you're guaranteed it will do something, and what you've got to show is the value you put there will cause no harm, so that you'll end up doing something that isn't too bad. That is the kind of default case of it just says, oh, I don't know what's going on here. Next.
Carried on from when you had the true false.
Yeah.
The answer. Obviously, I know that's Boolean already, but was that fair Boolean?
Yes.
Just that being a Boolean
Well,
was enough. Or...
So you've declared ans to be a string, so you can't use ans as a Boolean. Ans is a string. So what you actually need is to declare something else. Instead of calling it ans there, you call it b, and what you need is to declare Boolean b. It's a different variable holding a different value, and then all the way through. It wouldn't compile. The compiler would complain that you've declared something as a string and then you're using it as a... Yeah. So it would give you an incompatible types message, because Boolean is not compatible with something being declared a string. And that's really what the type system's there for. When you make mistakes and get confused and declare something as one thing and then use it as a different thing, somehow you're confused and the compiler's there to tell you, oh, that doesn't really make a lot of sense, go and think about it again. Okay? So Boolean is just a type, like int is a type or string is a type. So the Boolean b is just declaring a variable that can hold true or false values. There, in that program, there's not really a lot of need for it. In other situations, you might need it where you then do something later on. If I've got time at the end, I'll show you a situation when you actually would use a variable. So you might return the Boolean, and then it's a method that when it comes back, you know whether they answer something correctly or not. Because if what you wanted was them to have named a pet, and then you're going to go on and try and have some conversation about them having a pet, and the program prints a line like, oh, I'm glad you like pets, I have a pet too, it doesn't make sense to their answer. You might return a Boolean and then have an if statement. If their answer was true, then say something about you having a pet too. If their answer was false, then you'd say something different like, oh, I'm surprised you don't have a pet, most people do. Or, So that would be in a different if statement in a method that called this one. So it would be something like answer gets the value pets, calling pets, and then if the answer equals true, print one thing else, something else. So it's the place where you call pets, where you jump to this method and jump back again. It would be in a completely different bit of the program. Maybe I'm just confusing you, in which case you should... Yes, it would be in the method that calls this method. So it might be in main, for example. Main calls pets to ask them about something friendly about pets. No, you would have to change it to public static Boolean pets and then say return b or whatever you call that variable. Okay? So have you people who are typing the register in for me haven't. Yeah. Just checking it's not in.
That was my.
No, it's there.
No, that's not me.
Is that your student number?
No, I'm on it. That's someone else.
Okay, that's probably what's gone
No,
wrong
no,
then.
that's not me at all. I've written mine, but that. The register-
Oh, you're saying that isn't you? Okay, that person's confused
Yeah,
then.
yeah, like,
Okay, well, I'll try and find it when the register comes back. Just keep adding your name to the register. Eventually, the people who are sorting the register out for me hopefully will do something with it. But if it asks you for a whole program or a whole method, then yes, you would have to write the class definition if it was a whole program. You'd have to write public static void main. You'd have to have a main method if it was a whole program. If it was only a method you're asked for, then you would need to do essentially what I've written there: public static and void, name the method or whatever type, public static int, whatever it is. So yeah, if it's asking for a program or a method, that's exactly what I want. If it only asks for a fragment of code, then I'm not expecting you to put the method headers and all the other stuff around it. Yeah? It's probably that you've got too many closed brackets. So don't have your closed brackets all lining up. Indent them. So what you've got is a class there. So everything here should be indented. So the only thing there in the same column as an open curly bracket is the closed curly bracket that matches. So you can see what matches what. Because that one matches that. Those two match. Those two match. Those two match. That one actually looks like it matches that, but see how hard it is for me to find what matches what, and maybe that matches that, but it's hard to see. So the first thing is indent, so that whenever you come to a curly bracket, indent like you have there you've gone in and then you come back, but you should have done that here, so everything here is indented, and that might help you to see what it is that's missing. But I'd need more time to look at it. So if you want to bring it to me at the end, I'll have another go at looking at it, or show it to one of the TAs tomorrow. Okay. No, in the lectures, in here, I'll have explained somewhere or other all of those things. But what I want is not you learning my answer to those definitions. What I want is you to be able to explain them in your own words, in the same way as I'm explaining things in my own words as I go along in the lectures. You can, yes, or invent your own metaphors, but if you do use metaphors, then make sure you link it back to the actual code, that we're not just talking about, boxes and countryside, that you make it clear how the metaphor links, that a box is like a variable. It's sort of an analogy that if one's like another thing, and that you actually do use the language of the subject as well. So we're interested in you being able to talk about variables and values and know what they are, not boxes. And most of the last session, once we allow for getting everybody sat down and started and collecting all the papers in, but I think it's going to be about an hour and a quarter. I'll have to double check, but it's not a 2-hour test, but it will probably use up all of the lab. There might be some time at the end for people to get things marked to ask questions, but not very much time. Last thing.
What is the actual benefit? So where you've got, I know it can be tricky. When you got, so where you start up here, you say, you're not just straight.
So you could have done, but then a Boolean is a much. If all you want is something that's two values, and you're going to use those essentially to mean true or false, then it's better to use true or false because it makes the program clearer that that's exactly what you're doing, and also it's slightly more efficient because a true or false value only takes up a small bit of memory, whereas storing a string, you've got to store the whole string. Comparing a string, you are comparing CAT, not just a single value true. Well, it would be, yeah, it would be clearer, it would probably run faster, but we're talking about small improvements. Generally use the type that most closely covers the concept that you're trying to get across. So sometimes that would be a Boolean, sometimes it wouldn't. Okay, this will have to be quick.
Not within the main concept, you have abstract voice string class.
Yes.
What is it?
P is just short for parameters. Sometimes I use A for args or args or params. It's just a variable name. You could call it wombat. It wouldn't make any difference. It's just a variable name. And none of the programs we've written so far use it, so it doesn't matter what you call it. What matters is if you do use it, you've got to use it consistently with whatever you call it. Right, let's get on. So, there's more detail in the workbook of stuff about if statements that I'm not going to go into the detail now. I might come back to some of it at the end, but I do want to talk about for loops as well, so I'm going to switch over to that. And cover for loops, and if there's questions or anything about either for loops or if statements, people can ask me at the end if there's time. And hopefully the bees that obviously are busy escaping out there are going to go away, but possibly not. That's probably workmen on the engineering building. Okay, and it's off-putting, but I'm going to do my best to ignore it. So what we're going to do now is, if I get this in the right place, is that the right place? No, that's not the wrong place. That's the right place. That's better. What we're interested in now is essentially the question somebody asked me earlier, but about can you sort of get the program to do it all again? If they did one thing and you want to do the same thing again, once you've left the program and the program's quit, can it be started again? Well, no, not without the user actually typing the Java command to get it to run again. So the answer to that is what we need is some construct in the language that allows us to say, do it again. And that's what this is the first step of. So what we're looking at is how do you write programs that follow instructions a fixed number of times? So instead of just doing it once, maybe I know in advance that I'm going to want it to happen 10 or 20 or 50 times. So can I write that into the program instead of the person having to run the program 10 or 20 or 50 times? So the way you do this is something called a for loop. And so you've got to be able to write programs that do this, and you've got to explain what is meant by a for loop and trace the execution of programs that have got for loops in. And somebody was asking me about the input and the print statement, and that's a slide that just shows what the print statement was. So print here is just a method that calls system.out.println. You pass a message as an argument, and I just pass that argument straight on to println. So in the previous programs, everywhere I was using print, I just got this method there, and everywhere I was using input or input string, I'd got a method like that that just packages up using scanners. So that's in the notes somewhere in the workbook. I'm not going to go into any detail about that. So this is the kind of sort of first thing. You know, it's obviously a topic close to my heart, people coming up late, and I want punishments for people turn up to lectures late. So I might use the traditional punishment that anybody walking in late or anybody who goes and sits on the balcony ends up having to write lines for me. So you come in late, you have to write out maybe 10 times, I must not be late for class. Now, you're all computer scientists now, or you're all programmers now. You can write simple programs. The moment I give you an exercise like that, the first thing you ought to now start to think to do is, can I solve that by writing a program? Instead of me having to write out these lines 10 times, why don't I just write a program, and then every time I'm late, I'll just run the program, and it will write the lines for me, and then I won't have to do any work, and I won't have to care whether I'm late or not. So I've told you, okay, you must write out 10 times, I must not be late for class. Can you write a program to do that? Well, yes, you can. You've been able to write a program to do that since week 1, essentially. So how would you do it? You would do it something like this. You would write system.out.println, I must not be late for class, system.out.println, I must not be late for class. And of course, now you've got a program, having put the class statement and put it in a main method, you've got a program that you can run that will actually do that. But of course, in writing that program, you've just written a lot more and done a lot more work than I actually set you to do, because instead of just writing out 10 times, I must not be late for class, you've ended up writing out system.out.println, I must not be late for class 10 times. So you've made more work for yourself. And one thing computer scientists don't like doing is making more work for themselves. So the immediate thing to ask is, can I come up with some better way of doing that? And can I add something to the language if there isn't something there that would allow me to do things like this without having to write it out 10 times? Because that's fine until I actually say, oh, actually, I really want you to do it 1,000 times. Write me 1,000 lines because this is the second time you've been late. Or do it 5,000 times. And then you don't want to be writing out, even if you're cutting and pasting it, you don't want to write it out lots of times. So this is basically the problem that for loops were invented to get round. So essentially what I want, actually I might switch to slides at this point. So this is just saying what I just said. You know, what we want is a better way. Every line is the same. So what we really want is some kind of Java command that just says, that's what I want to do, and I want to do it 10 times. So instead of writing it out over and over again, why don't we invent a command that says, do the following 10 times? Okay? So if we're going to do that, if we're going to add something to the language that allows that to happen, and this is essentially what the inventors of the early programming languages sort of thought through, what do we need? Well, just like with the if statement, what we needed is a word that says this is the thing that's coming. It's an if statement that's coming. So here what we want to say is we want some special word that says it's one of these repetitive things coming. That's what's coming up. So what we need is a new keyword to say we're about to do something over and over again. We'll only write it once in the program, but we'll mean to do it lots of times. So that's the first thing we need, to invent a keyword. We also then need a way of indicating what should be repeated. You know, what is it that we've got to do 10 times? So we need some way of indicating that. And then the final thing is we need a way of saying how many times to do it. Is it 10 times we want to do it, 5 times, 100 times, 1,000 times? So those are the 3 components that we've got to specify. So if we were inventing a really simple way of doing this, this isn't quite the way you do it in Java, but it's not much more complicated in Java. We want a keyword, so we're calling this a for loop, so let's use the keyword for. So basically what we're saying is for is going to be a special word. A keyword is just a special word in the language that means something different. You can't use it as a variable name, is essentially what we're saying. You can't use it as the name of a method. So whenever you see for, what you're going to do is then see the information you need to repeat something some number of times. How do we say what we want to do? Well, it makes sense to use curly brackets. Anything that's inside the curly brackets that follows the for loop is the thing that we're going to repeat. So this is going to say, for some number of times, repeat that one statement. Okay? And then the final thing we need, and following the syntax that we use for an if statement, we need to say how many times it's going to happen. And so I'm using a slightly simpler version of what you would in Java, but essentially what we're aiming for is to, instead of putting a test like we have in the if statement. We want in there something that just says, do it 10 times. Okay? So the rest of it is exactly like a Java for loop. That is something we're going to have to work on. Okay? So that's not quite how you do it in Java yet, but that's what we're trying to do. That's what it's going to mean for some number of times, do this statement. And essentially what it's going to essentially mean is do this statement and then come back and do it again and come back and do it again. So if I was wiring this up with rope, everything we've had so far, as the baton has passed down the lecture theatre, it's kind of gone down the stairs. What we're going to have now is a mechanism of passing the baton back up to the top. We're going to have some rope that loops all the way back to where we started and allows us to pass it back down again. So the loop at the bottom just takes you to the top, and then we've going to have some way of coming out. When we've got to the 10 times, we're going to drop out and carry on elsewhere. So that's what we're trying to do. This isn't quite the way we would do it. So why do we need something a bit better than that, slightly different to that? So let's suppose I'm clever to the fact that you might write a program to do this. So what I decide is I'm going to make you write something different every time. So what I'm going to say is make you put a number in the line. So they're not the same thing every time. So you can't just say do this 10 times because it's different every time. So what I'm going to do is get you to put the number in front, and that will make it easier for me to check you've done the right number. And now that program of just saying we'll have something that says do it so many times doesn't quite work because it's something different, okay? So for loops are slightly more complicated than that, in part to deal with this kind of situation in a nice, easy way. And what this boils down to is what I've asked you to do is keep a counter of how many times. And obviously, somehow the system's got to keep count of how many times because it's doing it over and over again. It's got to say in its computer brain somehow or other, oh, I've done it once, I've done it twice, I've done it 3 times, so it knows when to stop. Okay? And what happens is the actual for loop in programming languages tends to be slightly more complicated just to include that idea, well, you're always going to have a counter, so let's keep track of a counter, and then we'll have a fairly systematic way of doing it. So the way to turn that into something we can deal with is to notice that actually every line is basically the same. There is just some difference. So the difference I've just put there, I've put some question marks in, that's the only bit that's going to change for this particular problem. So we are going to do the same thing over and over again, but with that just one place where something is different. So what we really need to make this work so I can just write that statement out once in my program, but get it done 100 times or however many times, is have some way of having those question marks change each time. Okay? And so what construct do we already have that allows us to keep track of something but keep changing it? Well, that's just what a variable is. A variable is, I've been calling it a box. It's like a box. You put something in, you can later put something else in, and then you can put another value in. You can keep changing the value, but you always refer to it by the same thing you refer to it by whatever name you gave it. So we can just use the name of a variable, and at different times, that name will be referring to different values because there'll be a different value we put in the box. So what we really need is to introduce a variable. So what do I want for those question marks? I just want to put a variable there and then somehow make the variable change its value as you go around the loop to have the right things in it. So how do I do that? Well, the statement I actually want is something like this one down here. Instead of writing out system.out.println 1, I must not be late for class, that 1 is going to change to 2 and then to 3. So I put a variable there, I. And that's going to be a box that's going to hold a value, an integer, and I'll change that value from 1 to 2 to 3, and so on. And so I just tag that number onto I must not be late for class. And if the difference was somewhere in the middle, then I would just have to put plus I in the middle. It doesn't really matter where it is. Wherever that difference is from each line when we repeat the statement, I just need the variable. Okay? So what does this give you? It gives you what we actually do in Java and something similar in most languages, though sometimes the syntax is easier. What we do, we have a keyword, we have the text that we want to repeat, which notice I've included a variable in, which is the counter, And then you explicitly have a counter variable that you declare. It's a variable, so you've got to declare it. And you want to change it, so you have an instruction that can change it. And you have some test as well that tells you when the for loop's finishing. So now what we put in the brackets is actually this 3 separate statements, or actually 2 statements and an expression, that are there to keep track of the variable. So what this says is the variable counter in this for loop will be called I, it's an integer, and will start its value at 1. What this says, I++, that is just shorthand, so what we could have written instead of there is I gets the value I plus 1. I++ is just shorthand for an assignment. I gets the old value of I with 1 added to it. Go and look in I, find out what number's in there, add 1 to that number, and then store the new number back into the variable I. And so then the final thing you need is the test that says how many times to do it. So this is, we stop when I becomes greater than 10. So keep going is the way it's phrased. Keep going while I is less than or equal to 10. Okay, so this says for I starting at 1, going up to 10, increasing by 1 each time, do the following statement. So we'll print the same statement out each time, but because I is different, and because the print statement says go and look in I to get the value of I out, we'll end up doing something different each time. And that's all there basically is to repeating something some fixed number of times. If you've written some fragment of code like our if statement, and you wanted to do it 10 times over, you wanted to ask 10 different people what their pet was, what you would do is you would write that code and then just put a for loop around it. The code we've written so far, the instructions we want to repeat, just go inside the curly brackets. So going back to exactly an example we had before, I can find one of the well, let's go back to the very first thing we had. Suppose we've written this fragment of code, which is just the insulting program again, but what I actually want to do is insult 10 different people. How do I do it? Well, I can write that bit of code. How do I make that bit of code get executed 10 times? All I have to do is put a for loop around it. So it's the thing I want to repeat, so I can put it in the curly brackets, and then I put a for loop around it. And I then set the counter to be whatever I want it to start off. Let's suppose I want to do this 100 times. I starts at 1, I keeps going while it's less than or equal to 100, and I add 1 to I each time. And now I've taken something that the program before only did once and turned it into something that will do it 100 times. So for loops are there when you know exactly how many times you want the program to run. Here I know I want it to do it 100 times, so I can just take what I've done and wrap a for loop around it. Okay? So there are 2 ways you can think about writing a program like this. You can start by thinking, oh, let's ignore the for loop, and let's just focus on doing it once, and then you would sort of write that. And once you've written what you want to do once, then just wrap it round with a for loop, like I just did, put the for loop around it, and then you've got it doing it 100 times. Alternatively, you could start sort of from the top down and think, oh, what I want to do is I want something that's going to happen 100 times, so the first thing I'm going to write is the for loop. So let's write for int I equals 1, I less than or equal to 100, I++ to make it go up in ones. I'm doing something 100 times, so I'll write a for loop to do it 100 times. And now, having done that, I can start filling in the details of what I actually want to be done 100 times. So if you're given a question that asks you to do something in lots of times in an exam, or the tests or whatever, you can either think about it in one of those 2 ways. But if the question's asking you to do something lots of times and you don't put a loop in it, you're not going to get very many marks. So look for the bits in the question that say do it some number of times, how many times you do it, and then write the for loop first. And then you've already shown me you can write a for loop, you can write the bit that does it lots of times, even if you don't do it over and over again. Yeah. So if you don't add anything in there, so what you could write there is something that never becomes true. Sorry, never becomes false. So this says, while this is true, do this. So if you write anything there that never becomes false, so that it always stays true, then the thing will keep going forever. But you shouldn't, so we'll see later on a different kind of loop where you want this unrestricted sort of thing. For now, at least, when you use for loops when you definitely want a fixed number of times, and then you always use this sort of mechanism, exactly what I've written there. The things you would change is that and that. What's the start point you want to count from? What do you want to count up to? And that will very definitely do it a fixed number of times and terminate. So yes, you can manipulate for loops to be more flexible, but generally, if you're going to want something more flexible, you probably want a different kind of loop, not a for loop. And Java lets you do more than it is necessarily good for you, so it's very flexible and lets you do bad things. Other languages don't, and part of the reason for having different kinds of loops, so we'll see a while loop later on, is you want it to be clear what kind of thing you're dealing with so that somebody reading the program easily understands it. And if you write a for loop that doesn't do something a fixed number of times, that can actually be confusing to somebody reading the program. So the short answer is, yes, you can make it do things lots of times. The slightly longer answer is, but don't. The even longer answer is, well, only when you really know what you're doing. Okay? I've lost track of who was asking me the question there. Oh, sorry, I was looking at a row above you. I knew you were somewhere around there. Okay, does that answer the question? Okay? Any other questions about what's going on here? So at one level, this is really simple. Work out what you want to do, and then put a for loop around it. It gets difficult just in the situations where what's in the loop is going to change, and for that, you've just got to start thinking about what is it that's the same, what changes, and the thing that changes probably needs a variable there to keep track of it, and you just change the value in the variable. So, yeah.
So my question is, the last part where it's I++.
Yeah.
Is it, if you put I+1, it'll print out one line. If you put I+2, it'll print out two lines.
So it's not about how many lines it prints out. So I++ is just an abbreviation for I gets the value of I+1, just as I wrote it out, not there, but in the other version. You can write, there are various other shorthands in Java that I'm not going to go into, and you can use them, but they are all just shorthands for writing out an assignment like I gets I+2. So for now, if you want it to count up in twos, then you would write I gets I+2. But that's not missing lines out. What that, in the sense of missing lines of program out, it would be missing what it prints out. It would just count up in twos. The counter would count 1, 3, 5, 7, if you said I gets I+2 from whatever it starts at. Yeah? Yeah.
What happens if you just want to print a word within the printout line? You want to repeat something within the line.
Keep it all on one line, you mean?
The printout line, the system printout, you just want to print like two words within the line. What happens?
So if you only want to print out something within a single line, then you would use system.out.print instead of print line, if you mean not moving on to a new line. So anything you want to repeat 10 times, just write the command that does it once, and then repeat it 10 times by putting a for loop round it. So I'm not even sure I exactly understand what you're asking, but if it's more subtle than that.
Let's say the system drop out print line.
Yeah.
You have inside, I won't be loop anymore. You just want to repeat it more.
Then you would have to put that part only in a loop, and then you would probably build it up in a variable. So I can show you an example of something like that. So you would do something that I'm going to talk about next anyway, which is an accumulator variable. What you could write is something like result gets result plus if I outside the loop, because I only want to do this once, I set up a variable result which is an empty string, so it starts out with nothing in it. And then I go around the result and say result gets result plus no. So what does that say? It says add another string no on the end of what I've got there already and add another string on the end. So I'm not printing anything at this point. I'm just building up a string, adding something on the end, adding something on the end. And what this is doing is saying add 100 times no on the end. So it's going to be no, 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 no 100 times. And then at the end I can, after it's gone round the loop, so we're now outside the loop, I could now do a print statement that says print, a print statement that says, I can't do that, plus the result we've just built up, that string we've built up. And what that loop is doing is building up all the repetitive bit, and now we're just taking that result that we've built up, this long string with lots of no's on, and sticking I can't do that on the front of it and then printing that out. So that would end up printing out I can't do that, no, 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 100 times. But it would only print I can't do that once, and it would have 100 no's on the end. So that's where using a slightly more complex form of loop, where what we're using the loop for is to keep what's called an accumulator. So result is an accumulator variable. And I'm probably, if I've got time, going to show you another example of that in a minute. Okay, any other questions about any of this? So that actually is a very good question, because that's a really common thing that you want to do, variations of that, where you're building something up in a variable, and once you've built up the answer, then at the end, outside the loop, you want to just print out some result once. Okay, so one of the things you've got to be able to do is dry run programs like this. So, here's an example of a program that does something fairly simple, a little bit more complicated than the printing lines. This is just printing the 2 times table. So, what do we want for this? Well, if we step back a little bit, we want to print out the 2 times table. What we want to print out is a series of lines like this that says 2 times 4 is, and then work out what 2 times 4 is, 2 times 5 is, and then do a calculation that works out what 2 times 5 is, and so on. So if we do what I said before and put question marks for the bits that are changing each time, what we end up with is 2 times something is 2 times something. And again, what we've ended up, what is that something? What are the question marks? It's actually something that's counting 4, 5, 6, 7, and so on. And so what we just need to do is put this one statement inside a loop, and then have a counter variable, and then the counter variable will keep track of the things that change in the things that we print. And that's exactly what I've got here. Int I equals 1, I less than or equal to 10, I plus plus, 2 times, I've got I, so it will be 1 the first time, 2 times 1 is, and then it'll do a calculation of 2 times 1, and the next time round the loop, it will do it again, it adds 1 to I, so I is now, I was 1, I is now 2, and it will print it out again. 2 times 2 is, work out 2 times 2 is 4, so it will print 2 times 2 is 4, it will come round again, it will add 1, to make it 3, and do it again. 2 times 3 is 6, and so on. So again, all I've done is I've replaced this time in 2 places the thing that was changing by the variable, and in this case the variable is just the counter. Now I started to dry run that and work out what it's doing just by creating a box and putting sort of values in it. What we talked about last time is the idea of using tables. So I can do the same thing with a table to keep track of what's going on. And actually, how much time have I got? probably got enough time to do this. So what I would do, create a table just like we did before. Maybe what I would do is label the line so I can keep track of where I am. What happens when you execute this? You come in and you do that line once, and then you jump to that and do that test, and then you go in and do the loop, then you come round, do this, go back and do the test, and then go round. So you actually come in, go round the loop, which involves doing that, and so on. So if I'm going to dry run this as a table, what I would do is kind of have the line numbers to keep track of where I am. First thing on line 1 I do is I have a variable I and I set it to 1. I've then got a test, so with tests, you can do this with if statements as well. I would have a column that keeps track of the test, which is going to be something true or false. So it is asking is 1 less than or equal to 10. So I'm still on line 1, and what I do is ask is 1 less than or equal to 10. And the answer to that is true. And if it's true, then I go into the body of the loop and I go to line L2. And so what gets printed, so let me add a column for what's printed. What is printed is 2 times whatever I is 1 is, and then I work out 2 times I, 2 times 1 is 2, and that's what gets printed. And then I go back to line 1, but I do this bit of line 1, which is an assignment, so I change that to 2, and then I do the test again, so I now do is 2 less than or equal to 10, and that is true. So what do I print? I go back to line L2 and I print 2 times 2 is 4. And then I'll keep doing that, going round line L1, L2, line L1, L2, until eventually I get up to adding 1 to I becomes 11, and then I'll ask is 11 less than or equal to 10? And that's false because it's now bigger than 10, and so at that point I quit and I would carry on with anything that comes below. So I can use this table mechanism just like we were for sort of simple straight line code to keep track of whether what a for loop's doing. So if you're asked to dry run code with a for loop, you can just do it in your head. So one way of doing it is to write the English of, oh, it counts from 1 to 10, so it will do it 10 times. What it does 10 times is print 2 times something is 2 times whatever. Or you could just draw a table like this and keep track. And as you get to more complicated things, it's generally better to draw tables, even if you do what I just did here, which is a ... in the middle of it to keep track of what's going on. So is there anybody got any queries about what I'm doing there, about how you could dry run something with a loop in? And this also gives you a way, same kind of idea. How do you dry run if statements? Just have a column for the test so you can keep track of what the test is. Yeah. Shh. Yeah. If you put ... and it's very clear it's just a very repeating pattern, and you write the answer out in full, that would be fine. But you've got to put enough there to show me you know what's happening that as you go from one to the next. Chances are in a test I wouldn't give you a loop that does something 10 times. I would only give you a loop that does it a few times. So you're probably just as easy writing it all out. But what matters is it's a clear justification. So as long as you've given enough, and there I gave 2 examples before I went to to set up the pattern of what's happening. Once the pattern's clear, then I go to the ... part of it. Okay. So let me just skip to another example. Probably easier on here. Okay, so there is a program. While I find the state of it, dry run that using a table. So work out exactly what that does and what it prints out. And it is using an accumulator, so it's doing something like my answer to what he was asking there. But draw a dry run table. I've put comments there, 1, 2, 3, 4. The idea is they're sort of there as line numbers for you to keep track of just while you're doing the trace table. And while you're looking for that, I'll find the sheet that's got it on. So work out what it does line by line, but then also, if you can, work out what it does overall. Okay, we've only got a few minutes, so I'll go through this, but hopefully you've had time to start and think about it. So, ultimately, the table I'm going to end up with is that, but if we do it sort of line by line, first line, int sum gets the value 0, so we create something called sum, and we put 0 in it. We then go on to line L2, so that was line L1, and we'll only do that once. L2, create a variable called I and put 1 in it, and then also test if that value is less than or equal to 2. That's true. So if it's true, we're going to go into the loop and do line L3. And line L3 says, take the value of sum and the value of I, 0 and 1, add them together, so the answer is 1, and store that back into sum. So we lose the old value of sum and get a new value. And then what do? We go back up to line L2. So from this point, we go back up to line L2 and we do that bit and then that bit and then back in again. So I++ is just I gets I plus 1. So that means we take the value of I, add 1 to it, makes 2, and store the new value back into I. I is now 2. We do a test. Is I, which is 2, less than or equal to 2? That's true. So if it's true, we go in and do the body. We take sum and I and add them together. 1 plus 2 is 3. And we store that value into sum. So we cross that out and store a new value in sum. So we're on line L3 again. And then we go back and add 1 to I. So I now has become 3. And then we test is 3 less than or equal to 3. That's false. And if that's false, we now jump out of the loop. So this is where it changes. That is where we're inside the loop. We now jump to line L4, which is outside the loop. And what that done is just print the current value of sum. The current value of sum is 3. So what actually gets printed, if I did that right, is 3. So what you're doing there is just stepping through it line by line, keeping track of the line numbers. You know, I would actually draw this on the paper just to keep track of what I'm doing. make sure you do it in that order as you're going round the loop. You're doing that over and over again. So it's not actually just that statement, it's those 3 statements that you do over and over again. And then eventually whatever is at the end. What would be the difference if this program had an extra print statement in here? If we actually said system.out.println sum in there, would that print 3 out lots of times, or would it do something else? Well, no. What we would be doing is that line, let's call it L. Every time we've done L3, we would do this other line, and that would print out the current value of sum. And so what's the current value of sum when we get to it the first time? It's actually 1, and then when we get to it the second time, it's actually 3. So if I got that right, it would print 1, 3, and then 3 outside the loop. So you've got to be careful about what's inside the loop and so gets repeated, and what's outside the loop and only happens once. Okay? So it could be outside the loop before, outside the loop after. It's the things inside the curly brackets that are the main commands that are repeated. Okay, I've run out of time there, but that's the kind of thing you're going to have to be able to do in the test. Write programs with for loops, write programs with if statements, write programs with records, variable declarations, assignments and so forth, and dry run them. Be given a program like that, be able to work out what it does. So practice doing it. Oh, and explain the concepts as well. Next Tuesday, yes, in your labs. I might cover them a little bit next week maybe, but there is actually a document that I wrote on the website that is just about getters and setters. And that's still not helping. Oh dear, I need to write more then or something.
The problem with it is I used it for the mini project. When it compiled and worked, it compiled correctly, but every time it tries to get a value, it doesn't name something, it just returns null.
That's probably something about whether you were trying to return the whole record or returning bits of the record. So if you're returning a record that you haven't actually done a new, so you've missed out a new statement, then you might end up with a null value for the record. So it might be that you just forgot the new statement. So basically, at some point when you create the record in the first place, you've got to do the new student, new whatever, to create something. And once you've got one, so S1, or student S1 gets the value new whatever, that's turning it from being a null thing to actually something that points someplace, and then putting values in it. So it's almost certainly that line you just missed out. But the main thing that matters at this stage is that you understand calling methods and returning values from methods and how you pass things arguments in methods. Yeah? Can we have questions outside at the back, because there'll be another lecture coming in. So let me just clear up and get everything outside. If you form a queue at the back, I'll come out there straight away. So I'll answer questions outside at the back.
I just want to confirm it's alright.
I can't look at something while I'm packing it up. The moment I stop, that means I'm going to get in the way of the next person. So you can ask me as soon as I get out the back of the lecture. I'm out of the way. Anybody got the other registers? Just out the back there, yeah.